And quickly, introduction, WindowsPerf, you know, it's an ARM project, it's open source, it's under Linaro umbrella. It's designed to help people use PMU from the command line and as a backend to other GUI tools. We are LinuxPerf inspired. We had a very similar command line. We are not trying to port LinuxPerf to Windows. That's not the point. The point is to just expose the PMU and anchor PMU to the user space through a simple architecture of Windows kernel driver and user space application. We have to use we had to write Windows kernel driver to support certain features that are not available in Windows kernel yet, but they are available through driver. So we can do that. We can access all the features we want. Yes, quickly, we integrate with the telemetry solutions, as you learned just a moment ago, which is very valuable. We are also, we want everyone to understand that our tool is not trying to hint you or help you to solve performance problems. What we are trying to do is we're trying to show you some metrics and some other information to give you some clues how to work with your workload for a better performance, right? So it's not a tool that tries to, you can hook it to AI, I get in the future. But for now, that's what we're trying to do. For the telemetry solution things, we do three things. We integrate with the top-down tool as a backend. We get all this JSON data with events, metrics, and groups of metrics in. And what's more, we are using the use-stress micro-benchmarks from the telemetry solution team, which are also available open source in our ARM GitLab. These micro-benchmarks are saturating certain part of the SOC, for example, the load store or maybe floating point or L1 cache. And we are using these micro-benchmarks also to test indirectly if our tool is correct, right? Because we have some Silicon customers that that are saying, but how we know it's actually working correctly? Oh, well, we are running the L1 cache workload that was prepared by Jumana's team. And it's saturating these events on Linux and Windows, and it actually matches. So good. The design decisions, I will go quickly. We have a very permissive BSD license. It means you can take our software, you can modify, you can sell it. You can add something, you can send us a patch. There are no limitations to how you use our source code, but please remember the Windows kernel driver we release signed. So if you want to use your own WindowsPerf with modified kernel, you probably want to sign your driver if you want to distribute in your company, or you remove the restrictions from your Windows on ARM machines so you can run the unsigned drivers. For the kernel driver, yeah, like I said, we are wrapping around access to hardware registers and resources like PMU, Anchor PMU, to give you user space experience with those counters. And for the command line tool, the WPerf is the command line tool for WindowsPerf suite. So what it gives you a very similar to LinuxPerf experience if it comes to command line flags. Very similar, I said, not the same. Last thing that we did, we also output everything in JSON. It is extremely useful, not only for testing, so you don't have to parse the output, but also we also export some data to CSV files. CSV, yeah, that's right. So, but the JSON is very useful, not only for testing, but also for consuming by other tools, because like top-down tool, for example, which is written in Python. And we have that small ecosystem there with the Windows experience. So we have the Visual Studio extension, and then we'll talk about later. Visual Studio extension can run WindowsPerf. I showed you the last picture. Produce a nice heat map. You can navigate your source code in Visual Studio. Then you can use the WPA plugin for the Windows Performance Analyzer, which is part of the Windows Performance Toolkit. Just to visualize all the data that you are getting from WindowsPerf. In the future, or almost now, Everton prepared a very nice feature when we, on top of what we do here, we also integrate this data with ETW stream. So we get all that stuff from PMU together with all the extended trace for Windows, which is actually a really brilliant feature that lots of developers are working on, even our Silicon Bring Up are using and want to use. And so now Everton will talk about the road to Madrid from London in the last 1 year. Okay, here, buddy.
Thank you. Thank you, Przemek. So, well, where were we at Lenario Connect 2023? So we had just made our first binary release. We just released our first sign driver. We had just, I think we had just the seeds for sampling, basic DLL, symbol resolution. We had just released the first version of WindowsPerf DevGen, which is a tool we developed to help install the driver. And by the way, you're supposed to not necessarily need anything to install drivers on Windows, but a driver is a bit different. It's a kind of a software driver, so you need to actually create a software device. And we had just like basic JSON output. And what have we done like 1 year later? So we had like 9 releases, which means that we worked a lot. Actually, you had more than 9 releases, several bug fixes, several new features, memory leaks that we solved, several issues with stability inside the driver. One big issue that we worked last year was we no longer require all GPCs to be available to install the driver. I'm going to talk a little bit more about this in the next slides. We added the record command that you all saw working on the last presentation. We also add basics export to perf data, which is kind of interesting. You can go on Linux perf and open our file. It won't solve the symbols because it can read PDB files, but it's actually quite interesting. And we also included a library and some extra options to configure the driver itself and some major. And this is actually something that we've been working on since the beginning, which is some upgrades to our testing infrastructure. We now have more than 500 tests, right? So yeah, it's it's quite a huge testing infrastructure. And we also added disassembly support for sampling. And oh yeah, I forgot to mention, this was March 2024, our last stable release. And now we have also, on April, we did a beta release with some very interesting new features, locking and unlocking, acquire and release PMU resources, some very early seeds for device tree support, and the prototype for ETW output. I'm going to kind of talk about all of these items later on. So record. On latest early versions of WindowsPerf, you actually had to first spawn your process manually, pin it to the CPU manually, and then grab the PID, go to WindowsPerf, start sampling. So this is very tedious, very error-prone, and actually some other problem was the fact that on our Ampere Ultra, which has more than 64 cores, you actually couldn't do this on the command line because the DOS start affinity command did not work because Windows separates when you have more than 64 cores into processor groups. And what happens is start affinity doesn't work in that case because you can't actually select the processor group. So yeah, it was a great hassle. You had to open Task Manager and manually select the core, so it was very complicated. We worked on this, so now you can just spawn through the command line. You just use /, and you use the .c to pin your process to a particular core, and it's very helpful. Everybody was requesting this, and it brings WindowsPerf much closer to LinuxPerf. So one of the synthetics examples that Przemek showed on the last presentation, I'm just showing it here once again so you guys can refresh your memories. So see, this is the SIMD hot function, is of course designed to stress out SIMD instructions. And so here is, I created this slide because there's a very common misconception of what sampling is actually doing. So sampling is a statistical process, right? So it will not count exactly all the events that are happening. what happens is every time the counter overflows, an interrupt happens, and this can have been generated from any part. What we do is we check the core, so it matches with the core that you're actually installed in your process here. And if it matches, we just return the sample, and WindowsPerf actually resolves this sample. And if it's in the address space of the process that you spawned, then we store it. So there's actually quite some noise, not too much, but when we can't resolve it, we just add it as unknown. But what happens is every interaction, since it's a statistical process, can give you somewhat different results. So I'm showing here like three different runs of this same command. And annotate, as Przemek mentioned, will give you the function and the line number. So you can see here that we had 3 runs, and on the first run, we didn't even had any counts on 51. So another interesting thing is that frequency here is something that you can use to kind of set up how many samples you get for this particular event. So since we only get interrupts when the counter overflows, we subtract frequency from the maximum value. So if you get a very small number, it will overflow several times, and a bigger number, it will overflow a bit less. So you can kind of control the frequency of this event. And so the timeout here, and yeah, so this is just to show how the statistical nature of things. People usually use sampling, kind of expecting to be like counting, that you just count the number of events on your workflow. So this is not how it works. Okay, so for disassembly, we use 2 things. The DIA, the debug in interface access SDK from Windows, and LLVM's object dump. And what happens is with the DIA, we read the PDB file, so we know every address of every function, of every instruction, of everything. And with LLVMs, we grab these addresses. When we grab the program counter, we know what's the line, so we know the address space for this particular line. We use object dump and grab the disassembly and show it to the user. So as Przemek mentioned, of course, there's the skid, so it's not like 100% accurate. And when we move to SPE, this is hopefully going to change. So, this is a bit hard to see. But anyway, so this is essentially the same thing that Przemek showed on the last presentation. So here is the line number, the number of hits for this line, the instruction address that we solved. And this is the disassembly for this particular line 53. So if we go back here, so it's this line, which is essentially the most important line, which is the one that got the most hits. And then number 8 is just the for loop, right? And you can see here then instruction address 13A34, which is this one, is particularly reasonable for our workload here. Okay, so the WindowsPerf library, I think the most important thing to understand is what it is not. So a lot of people try to think about when we say WindowsPerf library, think that it's like a very low-level library that you can access like the counters and the PMU and everything like very easily from C. This is not the case. The WindowsPerf library is just a wrap-up of the WindowsPerf application command line. So you just have the same commands. There's no special access. You're bound to the same commands that we have in the command line, and was majorly contributed by Qualcomm. They had the requirements on their team to do it. So I just gave some examples here. This functions like WPerf sample, WPerf stat, list, and version. So there's no like low-level access. There's nothing that you can't do on the application that you can do with the WindowsPerf library. Okay, so now we start to talk a little bit more about the beta features that we are going to release in stable versions in the future. So the first one is locking and unlocking the driver access. And this enables like easier control over other people's stopping workflows that are taking like considerable amount of time. It's quite common for people to be running workflows for several hours, maybe 10, 12 hours straight. And on WindowsPerf 3.3.3, we kind of did an emergency solution to this. We on device I/O control, we just changed the driver access to exclusive. So you can't even like open WindowsPerf, nothing happens, it just crashes. Kind of crashes, no, it's like nicely quits without giving you much information because it can't talk to the driver. So you won't be able to like WPerf version, WPerf test, nothing works. So to actually change this, we inserted some sort of session state inside the driver. So the driver knows who's actually using it, that it's actually in use. And if you are making a call and you're not the one that's actually using it, it will not enable you to do, but it will let you know that it's locked. So you can, if that's the case, you can actually even use the force lock command line flag to actually grab the lock. And oh yeah, so that's it. Acquiring and releasing PMU resources. So this is, as I mentioned, we had this issue that when you install the driver, you were required to have all GPCs available. And what we realized quite quickly is that some test devices don't have all the GPCs available. So people complained about this like very early on, and we struggled to have a meaningful way to actually. Oh, sorry. Good point. GPC is a general purpose counter. So one of the PMU counters. We have the general purpose counters, and we have like special purpose counters. So yeah, the GPCs, in case of the test machines, some of them were actually allocated by default. So on those machines, you could never actually install WindowsPerf. We solved this on at least on 3.3.3. You can now install on test devices. But what we later realized is that inside the whole Windows performance analysis workflow, you have tools like XPerf, for example, that also require access to GPCs. So if you want to run like XPerf, with some PMU measurements, like total cache misses or something like that, you would need some GPCs available. And what happens is we had not only to be able to install it, we had to be able to run WindowsPerf with a varied number of GPCs. And what acquire and release is doing is actually every time the session starts from the lock and lock, it acquires all available GPCs. And every time it finishes, it releases all of them. So without this, when you wanted to run XPerf, you actually had to uninstall WindowsPerf, start XPerf, install WindowsPerf, then start to run it. So now all you have to do is just start WindowsPerf, and it will grab all the available GPCs and just run it. And so XPerf can run along WindowsPerf just fine. Okay, so I think I had to do a small intermission here because most of us are probably just Linux developers and are not really aware of what's the performance measurement workflow normally goes on Windows. And so I want to give names and meanings to all of the words I'm saying. So ETW is Microsoft ETW is the event tracing for Windows. And it's a mechanism to trace and log events. You can use it to debug the current system status or like performance measurements. If you go on Windows, like the default tool you have installed already is the event viewer, which I gave a very small importance here, which is just used for diagnostics. But what somebody will, a person that's trying to measure performance on Windows would normally do is they would start the Windows Performance Recorder, and it has already a bunch of pre-installed profiles here, and you would select the profiles you want, and then start the recording, do whatever you want, then save it. It will save to an ETL file that you can open on WPA, which is the Windows Performance Analyzer. And it's a very powerful tool. It will give you a bunch of statistics, graphs, tables, a bunch of information. You can even grab information about the DPCs running, the instruction handlers, or whatever. So it's very, very interesting. And we try to integrate with all of that. And how do we do it? So ETW, the event itself, is just an XML file. So you declare a manifest, say what you're going to output to ETW, install the manifest, and just define your own profile for the Windows Performance Recorder to let Windows know that you're reading from, saving from this manifest. And then finally run it, and that's it. So this is what we've done, actually. So we added two macros here. You can enable ETW tracing to output ETW from the driver, and enable ETW tracing app to enable ETW output from the application itself. So why would you do this? The driver has way more precise information, so it knows exactly when things happen, but it knows nothing more than that. So we just know like hexadecimal numbers of events, and maybe the GPC that is running at most. In the counterpart, the application knows a bunch of information about the events, but has a way less precise information. So you might want to have more precise information with less with less extra things, less accuracy, or you want to have both. So we are going to release like both the application and the signed driver that outputs to ETW. It will actually complicate our release process a little bit, but we'll give the customers the extra option to have ETW tracing information. So all we had to do is, as I mentioned, just have our manifest, you install the manifest, and to actually make Windows Performance Analyzer understand this, we had to develop another Windows Performance Analyzer plugin to actually understand this. And so here's an example output. Here is the Windows Performance sample, the executable I just showed a little bit earlier. It's running here. You guys can see the execution time, I guess, the CPU usage. And right here, you can see the information from the app. So every time a sample appears to the application, it's an ETW output here. Here's the value. So it's very hard to see, but here is like cycle, VFP spec, and LD spec, so it knows what events are those, and it actually has more information about the core here, and it even knows like the event index, event name. This is a prototype, so we could have added more things here. So this was just to show that the idea makes sense. This output here is actually from the driver, so you can see much more information. You can see that when the samples are about to be sent to the application itself. So yeah, that's it. Okay, so this is now how the architecture is looking. It's way more complicated than it was at the beginning. So now we require the DIA, we require access to LLVM object dump, PE file, the PDB file, the source code. We are reading all this information from the PMU, which right now we just support core, DSU, and DMC, and we plan to, in the future, also support SPE. The PMU talks to the driver, and the driver talks to the application. Here we have our main features, like counting and sampling. Counting and sampling both output to JSON, which are read to either directly to the user or through the WPA plugin and the extension that you're going to see in the next presentation. And now it also outputs to ETW. So this is like the future version of the slide Przemek showed a little bit earlier. So we have the JSON output and who consumes it, and now the ETW output that's output to WindowsPerf, that you read to Windows Performance Recorder, finally through the Windows WPA with the WindowsPerf ETL plugin. Finally, but not least, one of the things that we heard like since day one, practically, I guess, I complained that customers wanted to write their own driver, right? They wanted to make changes to our driver. And making changes to our driver is, unfortunately, a nightmare. And it's very error-prone. It's very easy to get something done incorrectly. It's hard to test. So it's like huge. Windows drivers are written in C in a very... I don't want to give like my opinion, but anyway, they were really trying to. Well, we want to change this, and what we are going to do is we're going to add a sort of device tree. So we're giving like the customer the option to actually write his own driver based on very much simpler drivers that we are kind of rewriting, and he'll be able to just with some simple IOCTLs, answer if he's a core driver, a DSU driver, a DMC driver, an SPE driver, and what sort of operations he supports, like stat and sampling. And all he has to do is just use the same GUID that WindowsPerf uses. Right now, we already have the tech command, so we are very early on this, but it's the prototype seems to be working, at least the idea. So yeah, as Przemek mentioned, those are the Visual Studio extension that Nader is going to talk a little bit more about in the next presentation. And this is the WPA plugin. This WPA plugin is different because it just reads directly from the JSON file. So it's not exactly the same thing as the WPA plugin ETL. And well, this is our roadmap. So the two main things that are left to be done is ARM SPE support and ETW trace. Disassembly on annotate is already there. Driver resource lock and lock is already there. And hopefully beyond 4.x, we'll have everything packed together into a easy to install bundle with all of these components that are growing exponentially. And device tree features and further IP blocks. So this is essentially the same reference list as we already showed. We have a bunch of blog posts. We try to, as Przemek mentioned, have a blog post for each great release we have. We added stuff to the learning path and some more additional resources, and I think that's it. So any questions?
Good talk, Everton. You mentioned in one of your slides that you need the LLVM PDB. Is it
object dump?
Object dump. Is it tied to an LLVM, or can you have an MSVC compiler output or a GCC compiler output?
No, you can have whatever. And it can be, you could have it being compiled by MSVC, LLVM. Well, we haven't tried GCC, but I guess it's probably compatible.
LLVM comes as a part of Visual Studio installer, so it comes for free. So when you install Visual Studio and you install other dependencies to WindowsPerf, if you want to develop on it, you also install, you can install the LLVM toolset, and this comes together with it automatically. You just have to run your shell together with Visual Studio environment. you can extend WindowsPerf to use a different object dump. You can, but that one comes for free in the ecosystem already provided by Microsoft. So that was a low-hanging fruit. Until now, no one complains, and the tool works well, and it's fairly modern, well updated. It's also very easy to use as well, so it was very easy to implement.
I saw that you had a note on the slide saying that you quickly realized that you need to align to XPerf, but could you comment on that?
So XPerf is another performance measurement tool on Windows. It comes with the Windows Performance Toolkit, and it's normally used by people to have, for example, one of the events that Lina was talking about. So like, context switches and all of this. So you have the option to use like the -- PMC resources or something, and you can actually measure stuff from the ARMS PMU. They have defined like generic events, total cache misses. There's a list there, but you can also even use raw events. So you can do like basic counting with XPerf already. So someone might have already a workflow where they use XPerf and they just want to use WindowsPerf for some extra measurement or like metrics or something like that, which XPerf does not support. So that's the thing.
Thanks. So are you planning to support XPerf? How do you close that?
No, we're just planning to live together in harmony, in peace.
Okay, so it's a separate tool.
Yeah, it's a separate tool. It's from Microsoft. We just want to run together along happily ever after. And we're not going to touch XPerf, never, I guess. So.
Yeah, and so also this came out when Everton was using XPerf. So what XPerf does, it can just allocate PMU counters. So it's we can just use XPerf to test if we can allocate the rest of the PMU counters with WindowsPerf. That makes sense. Yes, and the XPerf is the command line tool that can facilitate extended trace for Windows recording for different events, software and hardware. But WindowsPerf is different in many ways. One of the ways is exactly telemetry solution support and also multiplexing. And we are more flexible about the IP blocks and what it can offer. But the XPerf, we just want to coexist with XPerf and other tools that are that are allocating general purpose counters on the system. It happens to some silicon vendors that on their test machines, their test software will allocate, for example, one PMU counter for something, like CPU cycles. They will not use the AMU for other fixed counters for a reason. They will use one GPC, but we were greedy allocating the counters. Now with all the changes that Everton did, we are very smart how we allocate the resources, and we can coexist with other tools that want to allocate counters, basically. That's just for interoperability. We don't want to compete with other tools that are using the general purpose counters.
So you're saying that, for example, I could have a scenario where both XPerf and WindowsPerf are running in parallel?
Yeah, sure.
And you'll share the counters?
Yeah.
Sure.
I'm not able to show it here, but if you go here, you can actually run like XPerf with all the measurements, like all the Windows information, like context switches, everything that you want, and WindowsPerf information will just appear here as an extra sort of like information that you want. As Przemek mentioned, you can match. You see, the times are all like together.
Okay, thanks. So I think I get it. So if we have, so the question then is, as WindowsPerf will give you all the hardware events, at XPerf you could switch off the hardware counting.
Yeah.
Right. So
yeah.
then you could have all the system stuff coming from XPerf
Exactly.
side, and WindowsPerf giving you the right hardware metrics.
Yeah.
Is that the way to look at it? Okay, got it. Thank you.
Yeah. So exactly it for this. So it's also useful for scripting. Yeah. But at the end of the day, all the applications injecting to ETW should just work together, because hundreds and thousands of different sources of ETW events are injecting to the stream. We can't just stop people from injecting in XPerf just because we want to inject in WindowsPerf. Yeah, so that's why it was created. It came as a as a experiment, we were experimenting, Everton was experimenting with XPerf, and he noticed we have to uninstall the driver. It's unacceptable that one has to uninstall our driver just to use XPerf, for example. Especially that one can share a machine, right? Or run some monitoring tool in the background. It happens that customers are running PMU counters on nodes that runs for days. They care about certain workloads that are very long, taking a long time. It may just last there. So we don't want to kick them out from PMU.
LinuxPerf has a lot of soft events that are hooked in the kernel. Like, for instance, you can track scheduling operations, memory operations, network. Do you have something similar, or do you plan to implement something similar?
So the path would be to use something like this.
ETW.
So
You will use ETW. That's the correct way to do it on Windows.
Yeah.
I know that your mindset is, I'm on Linux, the perf aggregates everything, all the APIs from kernel are there, I can send a patch, life is great. No, in Windows, the workflow is different. The workflow that Everton just presented is there is extended trace for Windows. You are injecting there, and you can write some plugin to interpret your extra events there, and then correlate this is the Windows Performance Analyzer. That one aggregates in a visual way all the things that happened in ETW. You can filter, sort, cut, trim, and then analyze and zoom in and zoom out.
Yeah, so the soft events that if you want to, you use like the profiles here to select whatever other set of properties you want to have traced along with WindowsPerf or whatever. So WindowsPerf is completely unaware of kernel events or whatever. We can't know
software
this.
events. It's not.
Yeah,
It's PMU. It's a wrapper
just
for
PMU.
ARM PMU and other Anchor PMUs. Yes, it's basic IP blocks, hardware IP blocks. That was actually when we discussed with Microsoft, that's the right way to go. That makes sense? So we just follow their guidance. Actually, we just follow the requirements from big silicon vendors when we develop this tool. We don't have any, our own ideas how it should be implemented. They just say that's the workflow, follow.
Does the ARM64 EC, ARM64 format matter at all for Windows performance counters?
No, go on.
Yeah, so it does matter because it mixes Intel and ARM code. I actually face an issue from a customer. They send a message, oh, I have the DLL that is ARM64 EC. So if not everyone knows, ARM64 EC is the binary format when you can mix or access between, there's a boundary between ARM64 API and x86-64 APIs. And actually, I think Aladdin disassembled some code, and we can see actually the Intel code, because we actually can look at the Intel function being called from ARM64 executable, but we don't support the DLL. So answering your question, it does matter, and we don't have the support for ARM64 EC symbols in DLLs, because these symbols are prefixed, I think, with hash, if I remember correctly, and we can't interpret correctly, and we have an assert. We actually put an assert. For some reason, we have like 3. I actually kicked in. So we will add the support. I created a ticket already. It's a low priority, but we should add this. As ARM64 EC, just like the emulator are the building blocks of the Windows on ARM ecosystem till now.
Yeah, in the next coming years, you will see a lot of applications transition from just being x64 to ARM64, but then they would probably use ARM64 EC as an intermediary stage where they have plugins and things that are already x64 compatible. And
especially libraries, because Microsoft did not port all their libraries, system libraries, to ARM. Actually, the DIA SDK that we are using at the beginning was not ported. We had to use ARM64 EC executable for WindowsPerf to access it.
Thanks.
Yeah, this is actually an interesting question that we just realized, like, when the issue was created.
And that's why we support, so that's why we really appreciate any feedback from users. We actually encourage everyone to give that feedback. We know this is I will not say it's a niche tool, but performance analysis is a niche kind of martial art, I would say. But we do appreciate any feedback because people stumble upon different problems. Usability is one. We have a good documentation. But this kind of a corner cases, we have people that actually have access to the debug for Windows kernel, right? So we don't have access. So they are telling us we have all these weird things happening in the system. And these are the features. They actually say it's not a blocker for ARM64EC because one will not care about the mixed workload that much, to be honest, because you can't control how the emulator does things. You care about moving to ARM64 and measure the performance of ARM64 application. That's my, my point of view. Like go ARM64 now, immediately.
So, any other questions?
I think we're on time.
Okay. Well, thank you.